Hello classmates, today we will learn about mode assembly. First, let's learn some basic knowledge of mode assembly. A mode is composed of several parts or components with different geometric shapes and structural functions. The assembly of modes is the process of combining qualified parts and standard components through operations such as fitting, positioning, connecting, fixing, adjusting, repairing, and testing according to the assembly relationship and the technical requirements given in the mode design assembly diagram. In order to ensure the quality of the mode and its formed mode parts, the mode assembly has the following precision requirements. The parts of the mode should meet certain mutual position precision requirements, such as perpendicularity, parallelism, coaxiality. The moving parts should have relative motion accuracy requirements, such as transmission accuracy, rotary motion accuracy, and linear motion accuracy of various mechanisms. Guidance and positioning accuracy requirements, such as motion guidance between moving and fixed modes, or upper and lower modes, installation and positioning of cores and cavities, and guidance and positioning accuracy of slider motion, coordination accuracy, and contact accuracy. Coordination accuracy mainly refers to the degree of clearness over interference transition that should be achieved between the surfaces of the parts that cooperate with each other. Assembly requirements for stamping dies. The work content and precision requirements for different types of dies and assemblies vary. In order to ensure the assembly accuracy of molds, the national standards specify the assembly technical conditions for different types of molds. During mold assembly, it is necessary to strictly follow the assembly requirements specified in the standard for overall assembly inspection and adjustment. The following table shows the assembly requirements for stamping dies. When assembling stamping dies, it is necessary to ensure that the gap between the concave and convex molds is uniform and consistent. The pushing and unloading mechanisms should be flexible, and all moving parts of the convex mold should be smooth and flexible without any obstruction. The screws and pins used for fastening should not be loose. The verticality and tolerance level of the assembled convex mold should meet the requirements, and the convex mold and the fixed plate should meet the requirements. When lifting, the mold should be stable and easy to install. Assembly requirements for injection molds. The assembly requirements for injection molds are shown in the table below. During assembly, the fixed mold seat plate and the moving template should be installed, and the parallelism of the plane, and the perpendicularity of the guide pillow, and the guide sleeve to the template should meet the regulations. When closing the mold, the end face of the reset rod should be in contact with its contact surface. Reliable action and no tightening or jamming. The pouring system is not allowed to have plastic leakage. Reliable action and no tilting or jamming. The pouring system is not allowed to have plastic leakage, and the slider movement should be smooth. After the mold is closed, the contact area between the slider and the mold should not be less than 75% of the design value, and the real limits should be accurate and reliable. Assembly process. Assembly is a series of assembly processes carried out in a reasonable process sequence, and different types of molds have different levels of structural complexity and precision requirements. The specific content and key points of assembly are also different. Preparation phase, including researching assembly drawings, cleaning parts, inspecting parts, and preparing tools. During the assembly stage of components and accessories, some parts can be assembled to form components before proceeding with assembly. Supplementary processing stage. Some parts have excess space that needs to be processed, and small errors require manual polishing. During the research and assembly stage, fitters are required to assemble these parts in an orderly manner. According to the structural relationships, inspection and debugging phase, the overall linkage detection of the movement of various parts of the motor mechanism and components should be carried out to ensure flexibility and reliability. Examples of a stamping die. Next, taking the nut plate mold as a case study part, we will conduct an example analysis of stamping dies. The assembly diagram of the nut plate mold is shown in the figure, with a total of 21 assembly parts. The next step is the process planning routes for these mold parts. The assembly process of stamping dies. Process 1. Preparation work. Check whether the various parts and processing accuracy of the mold meet the requirements of the design drawings, and check the uniformity of the clearance between the convex and concave molds. Check whether all auxiliary parts are complete, and prepare tools. Process 2. Assemble the mold frame. First, use the guide pillow as a reference to press in the assembly guide pillow and guide sleeve. Then, use the guide pillow as a reference to press in the assembly guide pivot wall on the lower template 13. Next, use the guide pillow as a reference to assemble the guide sleeve 11 on the upper template 1. Then, place the upper template 1 in reverse and assemble the mold handle 7 using the pressing method. Insert the saddle pin, and finally close the assembled mold frame and place it in place. Place a caution block between the upper and lower templates to support the pillow mold frame. Process 3. Assemble the lower mold. First, assemble the convex and concave mold 17 with the convex and concave mold fixing plate 14. Then place the assembled convex and concave molds together with the convex and concave mold fixing plate on the lower template, and assemble them with the lower template. Insert the pins and tighten the screws separately, and finally assemble the limit clamp 2 on the upper mold. Process 4. Assemble the upper mold. First, process the convex mold 6 into the fitting hole of the convex mold fixing plate 5. Then, reverse the upper template and place the assembled convex mold 6, convex mold fixing plate 5, and upper caution plate 3 on the upper template and screw in the screws. Close the upper and lower molds. Adjust the gap between convex mold 6 and convex mold 17. Test cut with a piece of paper. Tighten the screws of the upper mold after adjustment. Separate the upper and lower molds. Match the pinholes on the upper template 1 and the convex mold fixing plate 5. And insert the pin and tighten the screws. Then, assemble the concave mold 9 on the previously assembled upper mold part. Screw in the screws. Close the upper and lower molds. Adjust the gap between concave mold 9 and convex mold 17. Test cut with a piece of paper. Adjust and tighten the screws of the concave mold. Separate the upper and lower molds. Match the pinholes on the concave mold 9 and the convex mold fixing plate 5, and insert the pin and tighten the screws. Modular assembly limit column 2. Process 5. Assemble the unloading plate. First, assemble the unloading plate 8 on the upper mold. Screw in the unloading screw. Install the rod 18. And then place the rectangular spring 15 in the hole of the convex concave mold fixing plate. Assemble the spring 20 and the movable stopper nail 19 to match the hole of the lower unloading plates. Then assemble the lower unloading plate 16 to match the convex-concave mold, and screw in the unloading screw. Process 6. Trial mold adjustment. The assembled upper and lower molds are combined for trial molding, and the shape, size, and burr size of the test piece are inspected. The height dimension of the limit clamp is adjusted to determine the appropriate mold closing height. After completion, conduct inspection and verification, and make modifications where there are issues. This is the assembly process of stamping die parts. In this class, we talked about the requirements, methods, and examples of mold assembly. The content of this course,
Mold manufacturing process,
has come to an end. I hope you can practice more related exercise after class to consolidate their knowledge. Goodbye, everyone.